Find the indicated limit. Limit of x to the second minus x to the third multiplied by e to the 2x as x approaches negative infinity. Let's get started. To find the limit as x approaches negative infinity, we'll need some notes to go over first on the right side. The limit of e to the 2x as x approaches negative infinity will be going this direction, which is 0. And later on, we'll be using the limit as x approaches negative infinity of e to the power minus 2x, which is going to be going all the way up, meaning positive infinity. We'll be also using L'Hopital's rule with the infinity over infinity format. So we'll apply the limit to the derivatives of f of x over g of x. So the limit of f prime over g prime. The chain rule, the derivative of e to the x equals e to the x. Since I have e to the power 2x, we'll use this rule with the chain rule. And of course, finding derivatives of the inside part, x to the second and x to the third, we'll use the power rule. So the problem is the limit as x approaches negative infinity of x to the second minus x to the third multiplied by e to the 2x. This will give me a format or of the form infinity times 0. So to use this format, infinity over infinity, we need to rewrite the problem differently. And this is how we do it. Equals limit x approaches negative infinity, x to the second minus x to the third on top, x to the second minus x to the third, bring e to the 2x down, that makes it negative exponent, minus 2x. Now we are using the second graph on the right side, e to the minus 2x, but as x approaches negative infinity, we mentioned that we're going all the way up to infinity. So the format becomes of the following infinity over infinity. So now we apply the L'Hopital's rule. We're going to end up doing it 3 times. Limit x approaches negative infinity. We'll take the derivatives of the top part, which is called f of x, and the denominator, which is called g of x. Now f prime will be 2x minus 3x to the second, and g prime will be e to the minus 2x times the derivative of minus 2x using the chain rule times negative 2. Let's write negative 2 up front. Now, if you apply the limit or attempt to apply the limit as x approaches negative infinity, we have again infinity over infinity format. So we need to apply L'Hopital's rule again. Limit as x approaches negative infinity. Let's apply the derivatives. 2 minus 6x over the derivative of e to the minus 2x will be e to the minus 2x times negative 2 again. So we end up with positive 4. Since I have a negative 2 in the front, another negative 2 will make it positive 4. E to the minus 2x. This is also of the form infinity over infinity with the same argument. Let's apply the derivatives and apply L'Hopital's rule again. Limit as x approaches negative infinity derivative of the top part is minus 6, and down it's the same thing, but the negative 2 is going to show up front again using the chain rule, and that's going to give me minus 8 times e to the power minus 2x. You could simplify between negatives, the negative signs, and the 6 and 8, but clearly the top part is a constant. The lower part, because of the second graph, is going to go to infinity, and the final answer should equal 0. And that should do it.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.